Okay, so we will be starting with the next topic here, which was about modularization. This is a new topic for a lot of you, if not all of you. It talks about breaking a more complex task into smaller, more manageable tasks. This talks about the following topics. We will be learning about the modules which work with value returning, no value returning, parameters, and maybe an extra topic related to it if we get that far. But the bottom line is, so far, all of you have learned about main. What is the purpose of main? But what exactly is a method? It is a set of instructions by name. You come up with a name, and then you put a bunch of instructions under that name, and then you can call that name any number of times. Any time you call that name, it does what it is supposed to do based on the instructions packed inside it. Okay? For example, in your microwave, there are a lot of buttons. There's a button that says plus 30 seconds. What does that do every time you press? If the timer is already going, it adds 30 seconds. If the timer is set at 0, it adds 30 seconds to the 0 and get the things going. So there are only two instructions that are packed inside that button. One is add 30 seconds, and the other one is start if not already started. Okay, so the purpose of a method is to write a piece of code or a set of instructions that would allow you to run those set of instructions by name. And you can call it any number of times. That's the biggest advantage. You can call that name any number of times. So to get started, and right now you only have one method, which is main. What we want to do is we want to create another method which talks about the competition. So we will draft it exactly like the main. Public, static, void, competition. So if you notice, I'm using exact same words that I use for the main: public, static, void. The only thing different is the name. Instead of main, I'm calling it competition. And exactly like main, I'm using the opening and closing curly braces. I'll write a system.out.println FRC competition okay. FRC competition. So right now I have a name called competition, and there's only one instruction inside it. Let me add another instruction. System.out.println. The next instruction is, what is the date of your next competition? July 26, 2025. So we will be calling this method from main. How do you call a method? Calling method. To call a method, you write the name of the method and the parentheses. That's it. So what happens in this code is, I'll explain that in a minute. once everybody build this structure. Example is complete. So when you're running your program, you start running your program by calling the main. So main comes into picture. Main runs the following statement: welcome to online IDE happy coding. Once main runs that statement and displays an output to the screen, then main makes a call to competition. When competition gets called, competition displays FRC competition on the screen, then displays July 26, 2025 on the screen. Then the control returns back to main. Since main has nothing else to do, program comes to an end. How many instructions are displayed on the screen? So when the program runs, it displays 3 outputs. Now I want you to add one more instruction. Add one more instruction, competition. When you run it now, how many outputs will you see on the screen? 5. Line number 3 will run only once. Line number 5 will run line 9 and 10, so that's 3. Then line number 6 will run line 9 and 10 again, so that's total of 5. So first time the program runs, it will display this line, welcome to online. This line, welcome to online coding. Then the competition will make these 2 outputs. Then this competition will again run these 2 outputs. So it'll be total of 1, 2, 3, 4, 5. Yes. Okay. Next, let's create another method. Public static void. This method will be called students. And I'm displaying the names of students here. Now, replace the second call of competition with a call of students. So when I'm running the code, competition will call this instruction set, and students will call that instruction set. How many lines of output will be displayed to the screen? 4. 1 from team, 2 from competition, and 1 from students. So the whole idea of methods is to allow you to create a name and pack a set of instructions. Now, we are learning methods at a very basic level right now, at least at this point, where our methods are static and our methods are not flexible. The idea is to take this and create flexible methods. Okay? So create flexible methods. Is everybody done with this? Okay. Now, can the dates of competitions change? Right? So the team members may or may not be the same. Let's assume that they are the same team members, but the dates of competition can change. So right now, the way my program is, every time I run it, the date of the competition stays fixed. Okay. This is where our next concept comes in. The concept is called parameter. The concept is called parameter. Parameter is a value that you pass inside the body of a method from outside to customize it. Okay, so what's a parameter? It's a value that you pass from outside to customize. Okay, now think of microwave, for example. Can you customize your input into your microwave? Okay, if you want to warm for 2 minutes versus 2 minutes, 30 seconds versus 15 seconds, you're customizing the timer. So they have created a method called timer, and by pressing the buttons, you are feeding a value to the timer, which is making it run different number of times. Okay, have you ever used built-in features other than the timer of your microwave? For example, if you have to thaw something, you have to pick an option that I want to defrost. Then it asks you the next option. Do you want to defrost meat, poultry, fish, blah, 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 blah? You make a choice. So first choice was defrost. Then the defrost has a parameter. What is it that you want to defrost? What is the second thing it asks you? That's a parameter. You always pass the parameter in the parentheses. Okay. Then on line number 10, is that enough if I write it like this? No? Why not? Yes, very good. Thank you. So when you write the variable names, you do not put the double quotes. Double quotes is only around the message. So let me add a message. Date of competition is, and then I will write the variable. The date of competition is this. Okay. Now, will this code run? If I run it the way it is right now, it will not. Why? Because if you look at line number 5, I wrote competition with nothing in the parentheses. But on line number 8, it is expecting a value. That's why it will not run, because they don't match. So what does that mean? In common terms, parameters have to match. Otherwise, the program will not work. Okay, so let's pass a date here. On line number 5, the date is July 26, 2025. So what happens when you run this program, it passes this into the date. And that's the date that will be displayed here. Now, let's say another competition is announced. So I copied line 5 and I pasted it. Do you know of any other dates, or this is the last competition of the year you're doing in the July 26th? This is the last one for the academic school year? Okay, let me then make up a date. January 19th, 2026. Now you run it. What will happen is the first call will make FRC competition, date of competition is July 26th. Then the next call will say FRC competition, the date of competition is, and you will see a different date for both calls. And finally, this will display the names of the students. So how many lines of output? Total. 6. There's one from the main. Okay? Each call will give you 2. So that's 2 plus 2 is 4. One from main. And the last one is from the students. 6.
Mr. Said, I have a question.
Yes.
So can you scroll up a little bit to the top? Yeah, so see how like the public static void main string and it has the brackets? Why don't we have the brackets on the other ones too?
Oh, this is an array, and that's one variable.
Oh, okay.
Okay? That's why.
Okay. But why is the main one an array
Oh,
and the other ones are
that's
not?
how the Java developers have done it by default. There's a history behind it. We don't have to go into that because we don't use it anymore.
So we don't have to put the brackets on
No, no,
the
no, no.
other, right?
Well, this one you have to because that's how Java wants you to write it. But this one you don't have to because we are only passing a single value. We do not make any changes to the description of main because the compiler is looking for exact same definition.
Okay.
Right now, we have started to create our own methods other than main. So we can call our methods by any name and we can just pass any number of parameters and however we want them to be. But this is untweakable. You can't change that.
Okay.
Okay. So right now, the methods that we have created 2 methods. The first one takes 1 parameter. The second one takes no parameters. Yes. Yeah, we'll do that too. Yep. Okay, is everybody done with this? Okay. Now, do you only go to FRC competitions or do you go to non-FRC competitions as well? My question to you guys. Just FRC. Okay. But we will customize this a little bit differently, that we will make the method competition tell which competition you are going to on what date. So we'll have 2 parameters. So we'll have one for the date, and we'll add another one, string called named. So we have 2 parameters, date and the name. So instead of FRC, we'll just call it name. Okay. So the name of the competition is coming from the user. The word competition is fixed. So let's say on July 25th, you are going to an FRC competition. And on January 19th, let's say you are going to an IIT competition. So the first one on line number 5, when it runs, it will display the output, FRC competition, date of competition is July 26th. Then the second one runs, which is line 6. It will say IIT competition, and the date of competition is January 19, 2026. Okay? So you can customize however you want to customize it. Right now, we did an example with 2 parameters. Prior to this, we did an example with 1 parameter. Okay, everybody good? Okay, let's start main2.java, public class main2. So we will create a method called battery check with one parameter, of type int called level. Set this up. Convert these two comments to code. Public, static, void, battery check, that's the name. And it takes one integer parameter called level. This is what you should have written based on the two statements. Now, let's see if you can code the body. If level is less than 20, display low battery. Otherwise, display okay. Okay? Is everybody done coding that part, if condition? Okay. Now I want you to call battery check method and pass a value 18. And then call the battery check method and then pass the value 60. So you'll have two separate calls. If level is less than 20, system.out.println, battery level is low, else battery level is okay. That's the if condition. Since there is only one instruction associated with the condition, writing curly braces is not required. And when you're making a call, you will call battery level and pass 18 in the first call. And battery level, and you will pass 60 in the next call. So I'm removing these comments. So that you can look at the code itself. The code is very minimal. After I remove the comments, this is the code. So you're making two calls from the main to the battery level. The first call passes the value 18. When the value 18 is passed, it will display battery level as low. In the next call, when the value 60 is passed, it will display battery level as okay. So when you ran it, did all of you get two outputs? Okay. Now we will copy everything that we have written here. We'll open a new class, main3.java, and we will paste everything that we have copied. We'll paste everything that we have copied. Have we learned about this operator in this class? Okay. Does anybody remembers this operator from when you learned Java before? What is the name of this operator? Huh? It's the only ternary operator, but that's not what its name is. Conditional operator, right? What are ternary operators? The one that works with three things. Binary are those that works with two things, and unary are work with one thing. Okay. Do you know of any unary operators that we have learned in this class? Plus plus, minus minus, a negative sign. These are all unary operators. What about the binary operators? And, or, plus, minus, multiply, divide, equals. These are all greater than, less than. All of these are binary operators, okay? When do we use the ternary operator or the conditional operator? When do we use it? Anybody knows, remembers? Ashas, do you know? Okay. Ternary operators are used in place of an if condition if there are only two choices, if and else. I could literally replace these four things, these four instructions, with a single instruction set. Okay, but we'll do that in steps. We'll first do the first step. Will be an easier approach. Okay, so I will use a string variable called output equals to. I'll put a condition. Is level less than 20? And put a question mark. That's what the ternary operator does. It puts a question mark next to the condition. That means it is asking whether the condition is true or condition is false. Is everybody with me so far? Okay. All it is checking for is whether the condition is true or false. When the condition is true, what is the level of the battery? If it is less than 20, what should I tell user? Is the battery okay or is it low? Low. So if this condition is true, then low. If this condition is false, then okay. Everybody with me so far? Okay. So we're checking the condition to make sure if level is less than 20, if that is true, then low will be the value of output. If that condition is false, okay will be the value of output. So the value of output is determined by the value of level. Once I do this, I don't need any of this. All I need is one line of output that will say battery level is, and then whatever is the output. So as you see over here, that we have reduced the entire if condition down to 2 lines. Because all we needed to know if the value is low or okay. Once we determine that, we're displaying it. So go ahead and run it. You'll get the same output as before, where it will say battery level is low for the first call and battery level is okay for the second call. Everybody got this? Okay. Now copy everything in this example and let's go to the fourth one, main4.java, and let's paste this. We will now reduce it to a single instruction set. Line numbers 7 and 8 will now change to a single instruction set. How can we do this? First of all, delete the word output and put the parentheses in place of the word output. In your output instruction, where you had the word output, simply put the parentheses. Then copy everything to the left of equals, but not the semicolon. Copy everything to the right of equals, but not the semicolon. Copy it and paste it, just like that. And then delete line 7. You don't need line 7 anymore. And run it. This is how your program is now working. You call battery level and you pass the 18 as a value. It checks. Battery level is, it makes a check. Is level is less than 20, then display low. Then you make another call, but you pass a value 60. Is 60 less than 20? No, so display okay. So by using conditional operators, you can replace your if conditions by a single liner. If you are not planning on holding the value for any reason, you can use it directly in the output. So I've shown you both ways. You could hold the value in a variable like an output and display it, or you can directly make the decision in the output. Now let's add more than one parameters. In our main 2 example, or was it main 1? Sorry, it's the first example. We had 2 parameters and they were both of the same data type. They were both strings. Now, to the battery level, we will add 2 parameters where the first one will be the motor name and the second one will be an integer level. What is the purpose? The purpose is we want to notify which motor is at what battery level. If we have multiple motors and each one has its own battery. Okay? So we want to display motor name battery level is. Okay? This is how we are doing it. So we're adding the word motor name, which is the variable, concatenated that with battery level is, and then making a decision. Now in the parameters, I need to pass motors. So I can say, okay, front motor side motor. These are my two motors. So front motor is at 18%, and the side motor is at 60%. So when I run it, it will say front motor battery level is low, side motor battery level is okay.
I have a question.
Yes.
Can we make three conditions? Like, so 18, the battery level is low, and then 60, it's okay. But can we make it like, oh, the battery level is perfect, so it's like above 70, for example?
You can do that with conditional operators, but that'll make conditional operators a little bit complicated. So if you're getting that approach in the beginning, I would recommend then use if else.
Okay.
But it's doable. We're going to make that statement a little too complicated. It'll be too many parentheses to balance for you. Okay, is everybody good? Okay. Now let's start a new one called main5.java. Public class main5. Okay. I'll give you instructions that I want you to code. Code a method display sensor status and pass two parameters to the method. String parameter called sensor name and int parameter called reading. Now remember, I'm giving you comments at the top, but this code will go inside the main5, but it'll go outside of the main method because it's a separate method. You cannot write a method within a method. Then this is what I want you to do in the body. Display sensor name and its reading value if reading value is less than 10, display sensor might be faulty. To convert these comments to code, you have 7 minutes. So I'll check at 4:05. I'll check your screens at 4:05. So there has only been like a couple people who got 100% on the last quiz. One of the common mistakes people made was question number 8 was the common mistake. I asked third column. You know, I purposely wrote the column number first and the row number after. But when you read an array, you read row first, column next. So since we start at 0, row number 2 will be 1 and column number 3 will be 2. That's why the answer is C. The other one some of the people got wrong was number 7. I asked how many loops will be needed for a two-dimensional. So two-dimensional array has row and columns. So it's only 2 loops, one to handle the rows and the other one to handle the columns. So I didn't ask how many times a loop will run. I asked how many loops are needed. Also in question number 9, some of you made a mistake. When I ask what will the length property return for a one-dimensional array, the length property is the total number of items or elements, not the last one. The name of the method is display sensor status. So public static void, display sensor status. Two parameters, string sensor name, integer reading. I believe everybody got this far, right? Okay. Now, if reading value, first of all, you got to display the sensor name and its reading. Doesn't matter what it is. So the sensor name and its reading, whatever its reading is. Now comes your check. If reading is less than 10, only then you need to display sensor might be faulty. So you display the sensor name, and then you display its reading. Only if the reading is less than 10, then you display sensor might be faulty. Now you need to make a call from main. Display sensor status. Let's say the sensor name is ultrasonic, and the value is 5. And let's say we have another sensor. And it is at a value of, let's say, 30. So when the first call is made for ultrasonic, it'll say ultrasonic reading 5, and sensor might be faulty because ultrasonic reading is less than 10. But then when the next call is made, the reading is not less than 10, so it'll say, okay, the sensor name and the reading is 30. But the if condition will not run. So now it's constantly runs. So it constantly reports on its status. Okay? So anywhere you go, devices are telling you the status. What happens when you hit the speedometer, or when you hit the accelerator on your car? What happens? How do you know at what speed are you going? So there is an output, a return value. If it's a digital car display, you see digital numbers showing up on the dashboard, right? So that's basically a return. These are the kind, any function that gives you a value back is a return function. So even in robotics, if you have some kind of a screen on which the numbers show up, that is the value returning function. Okay? So what do you have to do to create a value returning function? You replace the word void with whatever data type value will be returned by the function. For example, in our case, I want to calculate and return battery percent. I want to calculate and return battery percent. So battery percent, what would be a good data type for a battery percent? Double. So public static double. Calculate battery percent. So voltage is the current reading, and maximal voltage is the maximum voltage allowed. and I want to calculate the percentage of that. Okay. How do you calculate percentages after division? Divide by 100, multiply by 100. Okay. So this is what we will do. Return. So first take the voltage, divide by the max voltage. Oops. Max voltage, and then multiply by 100. Oh, I should, you know what I should do? Maybe I should cast it because they're both integers, right? So I have to cast it to preserve the decimal after the division. Something we learned a few weeks ago, casting. So in a division, if one value is casted, then the whole answer becomes the casted value. Okay, now from the main method, we will have an output system dot out. Oh, well, double percent equals to calculate battery percent. Is that correct? 9 out of 12 is 75%? Yes.
I have a question.
Yes,
Why didn't we put void instead of double on line 8?
because both numbers are integers. When you divide an integer by an integer, decimal places are lost.
Okay.
So to
So
preserve the decimal, we casted one of them to a type double.
okay.
Mhm.
But what does void mean?
Say it again.
What does void mean?
Void means non-value returning. So all the methods we have created so far were all non-value returning methods. This is the only value returning method. So this is how it will run. So you will make a call to calc battery and you will pass 9 in voltage and you will pass 12 in max voltage. It will divide the voltage by max voltage and will multiply that by 100. Whatever number comes out as a result, that number will be returned as a value of the variable percent and will be stored in that variable. And next line, we're displaying percent. So far, we were not able to get a value out of a method. We were only passing values into the body of the method. Now, for the first time, we're passing the value and we're getting a value back. And remember, you can only get one value back.
So we can use return only once?
Within one method.
Okay.
Yeah. Yes. Can you calculate battery percent several times? Yes. Yes. That's the whole point. Set of instructions by name. You can call those instructions many times. Okay. Now, let's create a new class, main7.java. Okay. Create a method to receive two speeds and return average speed. So write a method that will receive two speeds and will return an average speed. Will return the average speed. Decimal, could be decimal, double, average, two speeds. So speed 1, speed 2. Return. How do you calculate average? You add two numbers and you divide that by 2, right? $15 into speed 2. 10 plus 15 is 25. Divided by 2 is 12.5. 12.5 was returned back into AVG1, which we displayed on the next slide. These are the kind of formulas that Mr. Azmat wants people to get a good grasp of, because you will see a lot of this kind of code all over your robotic files. You'll have methods that you will call, they will do the computation, and will return a result back. So that's why it is very important. Now, starting from today, is we are getting a little bit more deeper into what you want to be doing in the real robotics code. So far, up till last week, we were just doing building blocks. Next week, we'll start with object-oriented programming. Then you will get a little bit more deeper into the robotics, where we'll be building the robotics objects. And then this will come very handy, because these will go in those objects and will make objects talk to each other. So that's why it's very important. The next week's milestone will include everything till whatever we cover till today. So before we go into object-oriented, we'll want to make sure that you are getting things to be moving forward. Yes, everything from the beginning till today. Because think about it. Can you write this example and not know anything about variables or operators or data types? So it's all inclusive. You cannot avoid. So from the beginning, sounds scary, but the problem is you can't do anything if you don't start from the beginning, right? Can you write an essay and tell your instructor that I don't want you to give me an essay that includes nouns, because we learned that last grade? You can't do that. Same goes here. Okay. We will modify this example a little bit. Did everybody get this running? Did everybody understand what's going on? Okay. Now, sometimes you do not want the returning value to be held in a variable. You call it, it does its job, you display it to the screen, and things are over. So instead of putting it in a variable first, you can actually make a direct call from the output. Like this. You don't need line number 3. So what happens is you're displaying an output. In the middle of the output, you take a pause. And the pause is that you make a call to a method and you pass values. Method will do its magic and will return the output back to where the call was made from. Shoot. So that's it. We'll do the exact same thing. The benefit of this approach is that let's copy line number 3 and paste it a few times and change values around. You'll get 3 outputs, different averages based on the speeds. Now think about it, this running in a loop. Each loop iteration will make a call, we'll pass 2 values, we'll get 2 things back. That'll be our next thing that we would do here once everybody get to see this. There is a built-in function called random. It comes from the math class. Math.random. It generates a number between 0 and 1. So it's a long decimal number. Let's say the number it generated is 0.23. Okay, how can you make this 23? Times it by 100. Okay, times it by 100. So this is what we'll do. We will ask random to generate a random number, and we will multiply it by 100 to generate a speed between 0 through 100. And like that, we will generate 2 random speeds. Okay, so let's delete lines 4 and 5. We're going to work here. The line may go a little bit longer, so I'm going to just do it on 2 separate lines. It's possible to do that, right? So I hit an enter after the plus. First number, math.random multiplied by 100. And the next math.random multiplied by 100. Oops. Let me remove the parentheses, the extra ones. Yeah. Let's leave it like this. So we have 1 random number generated here, comma, another random number getting generated here. The closing parentheses is for the average. The last one is for the println. So that's why parentheses are important for you to balance. Every time you run it, you will get a different output. Depending on, or you may get a different output than I did here because your computer will generate a different random number. Okay. Okay, now we will loop through this process. So let's add a loop. For integer I equals to 1, I is less than equals to 10, I plus plus. Just add this loop instruction, just it, right above this. Since there is only one instruction associated with the for loop, writing curly braces is not even required. So this is the only instruction in the loop body. That's all you need to do. When you run it, how many times the loop will run? 10 times. So notice you will have 10 averages calculated on random numbers. You will have 10 outputs coming from random numbers. Now, if I change that loop to an infinite loop, of course, this problem will crash. But if it's a multi-threaded application, I could have a separate thread managing my average speeds, which is controlled by the main and is constantly reading the speed from the motors and calculating the average speed. Again, I'm giving you things at a smaller scale. When you start working with it at a larger scale, these will be the different components. I'll go in different places.